Welcome student. Today we will start discussion on the first topics of geomorphology. This topic is origin and evolution of the earth crust. This is a part of physical geography, first paper geomorphology. You know that geomorphology deals with the topics is origin and evolution of the earth crust. Getting well now? Actually it is associated with the first order landform. First order landform, you particularly must know that actually geomorphology deals with the study of the landform. There are three categories of landform, namely first order, second order and third order. Continent and the ocean are the example of first order landform. Mountain, plateau, the landform produced by volcanic eruption, earthquake or tsunami is called second order landform, and the landform produced by the agent of erosion like river, glacier, wind, oceanic wave are the example of third order landform. So as far as the question of first order landform is concerned, the topics is associated with the origin of the ocean and the origin of the earth crust. Getting well now? So you see there are three types of landform, you know, first order, second order and third order. First order deals with the study of the earth crust broadly, including continent and the ocean, and the most satisfactory theory to explain first order landform is continent drift theory. Continental drift theory is considered the best suitable theory to explain the first order landform. Actually, the origin of second order landform is based on plate tectonic theory. Plate tectonic theory explains the origin of the second order landform. Today, we will discuss continental drift theory. Continental drift theory, very important topics. Getting well now? Continental drift theory is very important. Now see, as far as the question of continental drift theory is concerned, the theory was the term, this is a combination of three terms. One is continental, second is drift, and third one is theory. Getting well now? Continent refers to the crustal part broadly. Okay? You know that uplifted part of the crust is referred to as continent, and subducted part which is covered of the earth crust, which is covered by the water, is referred to ocean. Getting well now? So actually continent is the first term, second is drift, and third one is theory. Getting well? What is the meaning of drift? Okay? So you see, the term drift was first coined by Antonio Schneider. Antonio Schneider was the first geographer who coined the term drift, and the meaning of the term drift, actually the term drift includes two phenomena. One is the fragmentation of crustal part, earth crust, okay, earth crust, getting well now? And second, also horizontal movement of the fragmented part of the crust. Getting well? So actually, as far as the question of drift is concerned, drift include two phenomena. First is the fragmentation of the earth crust, and second, the horizontal movement of the fragmented part. The two phenomena is combinedly referred to as drift. Getting well now? So why Antonio Schneider? Antonio Schneider was the first geographer who used the term drift. Okay? Actually, what was the objective? Why he used the term drift? Actually, you see, Antonio Schneider identified that in Alaska, this is the part of Alaska in North America, it is clear na? In Alaska and in Siberia, in Eurasia, there exists similarity of fossil deposition in the tertiary coal mines Getting well now? Actually, during tertiary period, vegetation got deposited in the interior part of the earth, and later it converted into coal now. So this is referred to as tertiary coal. Okay? So in tertiary coal mines of Alaska as well as Siberia, the same type of fossil are found, same type of fossil are present. Okay? So to explain this phenomena, Antonio Schneider used the term drift according to Antonio Schneider. Initially, Alaska and Siberia were united. Later, they drifted apart. Getting well now? So, actually, Antonio Schneider was the first geographer who used the term drift, and his objective was to explain the similarity of fossil deposition found in the coal mines of Alaska and Siberia. Getting well now? Again, you see, as far as the question of drift theory is concerned, the drift theory was propounded by Taylor in 1908. That's why Taylor is referred to as father of drift hypothesis, and he propounded the theory against the failure of contraction theory, which was propounded by Hall and Dana. Getting well now? And that's why particularly you see drift hypothesis is considered more advanced as compared to that of conventional contraction theory, which was propounded by Hall and Dana and later particularly supported by E.L.T.B. Mount. Getting well now? So since Taylor propounded the theory, that's why Taylor is referred to as father of drift hypothesis. But actually, you see, later Wegener particularly expanded the theory, okay? And this theory became more popular. So that's why in continental drift theory, we will mainly focus over the Wegener's continental drift theory. I said that the term drift was coined by Antonio Schneider, right? His objective was to explain the similarity of fossil deposition found in the coal mines of Alaska and Siberia. Taylor propounded the theory, and this theory is referred to as continental drift theory, okay? Also, objective of Taylor was to explain the origin of tertiary fold mountain, and also to explain why tertiary fold mountain are orienting either from north to south or east to west. Getting well now? But you see, as far as the question of Wegener is concerned, the objective of Wegener was quite different. Wegener was a climatologist. He observed certain phenomena on the Earth's surface which was not matching with the climatic condition of this area. Okay? So to explain this fact, Wegener expanded continental drift theory propounded by Taylor, and this theory became more popular. That's why Wegener's continental drift theory is normally directly raised in civil services exam. Getting well now? Now see, what type of phenomena he was trying to explain. The first phenomena was, you see, he said that he identified the presence of coal mines in Alaska and Siberia. Getting well now? Particularly you see, as far as the question of coal mines, presence of coal mines is concerned, coal is produced when large-scale vegetation get deposited in the interior part of the earth. It means for coal formation, vegetation is essential, and for origin and development of vegetation, you see, high temperature and high rainfall is ideal condition, and both these conditions are available in the lower latitudinal zone. Okay, that's why in equatorial zone there remain very high density of forest resources, but Alaska and Siberia both are cold climatic zone, and hence large scale vegetation growth is not expected in this area. Despite of this fact, he observed the coal deposition in Alaska and Siberia. It means presence of Alaska coal mines in Alaska and Siberia not match the climatic condition of this area. This was the first important question before Wegener. Getting well now? Second important aspect was, you see, he identified the boulder clay deposition in peninsular part of India, South America, Africa and Australia. Boulder clay is the deposition made by the glacier, and you know that glacier is moving ice body and it is associated with the cold climatic zone, okay? And hence particularly in cold climatic zone, the presence of glacial deposition is a common phenomena. But all these areas, including peninsular India, Africa and South America and Australia, are located in the tropical zone, but in this area, boulder clay deposition is found. Getting well now? So this also not matches with the climatic condition of the zone. And the third important aspect, which was the matter of investigation by Wegener, was he observed the fossil deposition of glossopatrys vegetation. Glossopatrys vegetation are the vegetation of the polar zone. That's why their fossil deposition is normally expected in the polar zone, but he observed, he identified the deposition of fossil of Glossopteris vegetation in peninsular India, Australia, Africa and South America. Okay, so presence of this vegetation or fossil of this vegetation not matches with the climatic condition of the zone. These were three important points, right, before the Wegener. And Wegener was trying to sort out the problem. That's why he expanded the continental drift theory, and hence Wegener's continental drift theory became much more popular. Getting well now? Now see, actually he expanded the theory propounded by Taylor's hypothesis. Since Taylor was the first geographer who propounded the theory, that's why Taylor is referred to as father of drift hypothesis, that is continental drift theory. But theory expanded by, enlarged by, modified by Wegener became more popular. Getting well now? Now see, what is the basic assumption of the theory, Wegener's continental drift theory? So you particularly see, as far as the question of Wegener's continental drift theory is concerned, there are Wegener's continental drift theory are based on two basic assumptions, Getting well now? Now see, the first basic assumption of Wegener's continental drift theory is, Wegener's basic assumption of the theory. There are two basic assumptions of the Wegener's continental drift theory. The first basic assumption is, prior to Carboniferous period, the entire landmass were united to form a single landmass known as Pangea. Getting well now? This was the first basic assumption of this theory. This continental part, the entire continental part, including Eurasia, North America, South America, Australia, Peninsular India, Antarctica, all were united to form a single landmass, and this landmass was united one and is referred to as Pangea, and Pangea is surrounded from all the sides by extensive water body known as Panthalassa. Getting well now? This is first assumption of the Wegener's continental drift theory. Actually, prior to Carboniferous period, the entire landmass were united to form a single landmass known as Pangea, and Pangea was surrounded from all the sides by extensive water body known as Panthalassa. Panthalassa is also referred to as primitive Pacific Ocean. That's why Pacific Ocean, since is a part of Panthalassa, is considered as the oldest ocean of the world. Getting well now? And northern part of Pangea is referred to as Laurasia or Angara land, and southern part is referred to as Gondwana land. Getting well? So this is the first basic assumption of Wegener's continental drift theory, that prior to Carboniferous period, the entire landmass were united to form the single landmass, and this single landmass is referred to as Pangea. Okay? Pangea means the entire earth, the entire continent, the whole continent, and Pangea was surrounded from all the sides by extensive water body known as Panthalassa or primitive Pacific Ocean. Okay, he said that in the central part of Pangea there were shallow water body too. Okay, and second basic assumption of the theory is, the upper part of Pangea is made up of Sial, and it exists in the solid state, and it float over particularly the liquid known as Sima. Getting well now? Actually, he said that the upper part of Pangea is made up of Sial and it float over Sima, and there is no friction between Sial and Sima. It means movement of Sial over Sima is frictionless. These were the two basic assumptions. These are the two basic assumptions of Wegener's continental drift theory. The first assumption is the entire landmass were previously, prior to Carboniferous period, united to form a single landmass known as Pangea, and Pangea was surrounded from all the sides by extensive water body. Getting well? And second basic assumption is the upper part of Pangea is made up of Sial and it float over the liquid known as Sima. When a Sial float over Sima, getting well now? So these are the two basic assumptions of Wegener's continental drift theory. Okay. Again, you see. Again, the second particularly important aspect is, right? Second basic aspect is actually he said that Wegener's continental drift theory. Okay, Wegener's continental drift. What is the basic assumption? Got it now? Actually, there are two basic assumptions simply. You should understand. Without basic assumption, no theory can be successful. Okay, we have to suppose something, and he stated that actually the entire landmass were previously made up of the single landmass known as Sial, and Sial was floating over Sima. The single landmass, right, known as Pangea, and Pangea is surrounded from all the sides by the extensive water body known as Penthelas or primitive Pacific Ocean. And second basic assumption was the upper part of Sial is made up of solid and it float over Sima, which exists in the liquid form, and movement of Sial over Sima is frictionless, means there is no friction between Sial and Sima. Getting well now? Now see, he says that prior to Carboniferous period, the entire landmass were united to form a single landmass. So actually, he given certain effective argument to prove the existence of Pangea prior to Carboniferous period. The first argument he given was, the first effective argument was on the basis of jigsaw fitting, right? Or juxtaposition. Suppose particularly this is one hand and this is another hand. If we will bring it very close, it will totally fit in each other. Now, so this position is referred to a jigsaw fit assumption or juxtaposition. You see, he said that the shape of Peninsular Brazilian High, this is Brazilian High of South America, and this is particularly Guinea coastal part, this is Guinea coastal part of Africa. Getting well now? So shape of Brazilian rise of or high of particularly South America and Guinea coastal part of South Africa is if the two landmass will be brought close to each other, they will totally fit. Okay. So this is referred to as jigsaw fit assumption or juxtaposition, right? It reveals that from this it appears that previously the two landmass were united, but later they were fragmented. Getting well now? Second important particular argument he given that actually the particularly rock constituting the age structure and composition of the rock forming eastern coastal part of South America and western coastal part of Africa are the same. It is clear enough? It again particularly support the assumption that initially they were united and later they drifted apart. So actually jigsaw fit assumption and age structure and composition of the rock of these two particularly landmass, eastern part of South America and western part of Africa is the same. That's why it is important particularly argument given in support of existence of united landmass. Getting well now? Again, see, second important particularly aspect he said that you see this is Scandinavian area, okay, and Scandinavian area, okay. Actually, in the eastern coastal part of North America, suppose this is North America, suppose this is North America, this is North America. So in North America, you see, in North America, actually in this area there exists a mountain known as Appalachian Mountain, okay, and in Scandinavia there is a Scandinavian mountain. Getting well now? So actually he observed that, Wegener observed that the age structure and orientation of Appalachian Mountain located along the eastern coastal part of North America and a Scandinavian mountain of Scandinavia is the same. Getting well now? Right? So actually he assumed that previously the two landmass were united. It means Appalachian and Scandinavian mountain were united one, and later they drifted apart. This is second important argument given in support of existence of Pangea. And again he said that you see the rock constituting the eastern coastal part of North America and age structure and composition of the rock forming western coastal part of Europe are the same. This also is the effective argument in support of existence of Pangea. Getting well now? Right? Again you see, he given a living example. What was the living example you see? This is Scandinavia, and there exist certain species along the Norwegian coastal part, and these species are referred to as lemming. Lemming are the species existing along the coastal part of Norway. Okay? Actually, lemming form a group and migrate in westward direction and are drowned in the water and die. According to some, the lemming poses the tendency to conduct collective suicide. But Wegener given the argument that initially Greenland was located very close to that of particularly Norway, where lemming used to go. Okay? But actually Greenland is moving or drifting with an average speed of 20 centimeter per year in westward direction. Right? Despite of this, that's why Greenland is now far away from that of lemming, that of Norway. But despite of this fact, lemming move in westward direction in the anticipation, right, to go to the Greenland. That's why they are drowned, and this tendency exists in the lemming species. So this is particularly living example. Okay, living particularly argument in support of unified landmass. That is, Greenland was initially united or very close to that of particularly Norway. Getting well? Again, see, he said he found the fossil of certain species which can move only on the landmass, right? But their fossil are found in North America, South America, Australia, Africa. How it is possible? So it is possible only when all the landmass were united, were united in the past, where these particularly species were moving around. Getting well now? So these are certain arguments given in support of the existence of Pangea. Getting well? Now see, actually Wegener said that prior to Carboniferous period, the entire landmass were united to form a single landmass, and after particularly Carboniferous period, right, fragmentation of Pangea started. Getting well? So you see, as far as the question of Wegener is concerned, Wegener said that three forces were responsible to cause fragmentation of Pangea. The first particularly force which was responsible for fragmentation of Pangea was force of buoyancy, which is referred to as Utplavanbal, given by, the term was coined by Archimedes. Okay, Archimedes stated that when any object is submerged under water, the object experiences upthrust, and this is referred to as force of buoyancy. Getting well now? So he said that force of buoyancy, since you know that this force is based on the assumption that upper part of the earth is made up of Sial, okay, and it float over Sima, that is in liquid part now, okay, and Sial float over Sima. So certainly, particularly, a upthrust operate here as per the Archimedes law, and this force is referred to as force of buoyancy. What is how it operates? It is clear now. It operates in upward direction, and Wegener said that due to force of buoyancy, you see, suppose this is Pangea, this is North Pole, and this is South Pole. Suppose for better understanding, so actually due to force of buoyancy, the landmass drifted, that is Pangea drifted in two parts broadly. Northern part started moving towards North Pole and southern part started towards the South Pole. Okay? It means force of buoyancy causes poleward movement. Getting well now? This was the first important force propounded, which was held responsible for causing drifting in the Pangea. Okay? The first force was force of buoyancy. Okay? You see, force of buoyancy is the first force. Getting well now? Now see, the second force he suggested, it is clear that force of buoyancy will always create poleward drifting of the continent now. And the second force which is responsible for fragmentation of Pangea, according to him, is differential gravitational pull. Getting well now? Differential gravitational pull. Differential gravitational pull, meaning in Hindi, is Bivedi Guttakarsan Bal. Okay? What is the basic concept of differential gravitational pull? You know that the central part of the earth interior, which is referred to as inner core, is considered responsible for gravitational pull of the earth, and gravitational pull of different amplitude operate in different part of the earth surface. In equatorial part, the force of the different gravitational pull is less as compared to that of the polar zone. It is clear now? So this concept is referred to as, this particular trend is referred to as, but a different amount of gravitational pull operating in different part of the surface is referred to as differential gravitational pull. Getting well now? So he said that differential gravitational pull is also responsible to cause fragmentation of Pangea, and differential gravitational pull causes poleward, equatorward movement. Actually, you see, the force of buoyancy cause the particular fragmentation of Pangea into two parts. Okay, actually, you see Pangea drifted into two parts. Northern part moved towards the north pole, and southern part moved towards the south pole. Getting well now? Okay. Actually, consequently, you see this Angara land and Laurasia approached near North Pole, and Gondwana land approached near South Pole. Getting well now? Okay. And the water of Penthelasa entered between the two, and this aquatic zone, right, came to be known as Tethys Sea. T-E-T-H-Y-S, Tethys Sea. Getting well now? And this phenomena was referred by Wegener as opening of Tethys. It is clear? So for opening of Tethys, different, you can say force of buoyancy was responsible now, okay, which caused particularly poleward movement of the continental part. And against the second aspect is, second force is differential gravitational pull. So differential, actually force of buoyancy causes poleward movement, whereas differential gravitational pull causes equatorward movement. Getting well now? Actually, you see the landmass which were near North Pole and South Pole, due to differential gravitational pull, started moving towards the equator now. That's why it is said that it causes equatorward movement, and due to equatorward movement, equatorward movement was due to differential gravitational pull, and you see the landmass which were near North Pole and South Pole again started moving towards the equator. Okay, that is, you can say that the landmass started leaving the polar zone, and this phenomena was referred by Wegener as flight from the pole. Getting well now? So there are two terms here you see. Actually, opening of Tethys was due to force of buoyancy, that is Flavanwall, and flight from the pole was basically due to differential gravitational pull. Getting well? And the third force which was considered responsible by Wegener for fragmentation or drifting of Pangea was the tidal force. Tidal force, you know that tidal force is due to the attractional pull exerted by the moon and the sun. Since moon is close to earth as compared to that of the sun, that's why tidal force exerted by moon is much more effective, okay, as compared to that of the sun. And Wegener said that due to tidal force, westward drifting started, right? Westward drifting of the continental part started. Getting well now? So suppose particularly North America or South America is moving in westward direction. Getting well now? So it was basically due to, according to the opinion of Wegener, it was basically due to tidal force, you can say. Getting well now? So in this way particularly Wegener explained, right, the fragmentation of Pangea. Actually again I am particularly concluding this aspect in the way that Wegener said that prior to Carboniferous period, the entire landmass were united. The entire landmass, united landmass, was called as Pangea, and Pangea was surrounded from all the sides by aquatic body, water body, and this was referred to as Penthelasa or primitive Pacific Ocean. Okay, this was the position prior to Carboniferous period, and for particularly existence of Pangea, Wegener given particularly certain argument like geographic assumption, right, structure, age and orientation of Appalachian mountain and Scandinavian mountain, right, age, structure and composition of the rock constituting eastern coastal part of South America and western coastal part of Africa. Similarly, age, structure and composition of the rock constituting eastern coastal part of North America and western coastal part of Europe. Okay. Again, movement of lemming in westward direction also particularly support the assumption that prior to Carboniferous period, the entire landmass were united. Okay. Again, particularly Wegener said that due to three forces, right, fragmentation of Pangea started. The first force was, you see, force of buoyancy, second is differential gravitational pull, and third one is tidal force. Okay. So as far as the question of force of buoyancy is concerned, it was based on the assumption that upper part of Pangea is made up of Cl which exists in the solid state and it float over the liquid known as Sima. Okay. This was the first particularly, it is clear na? So due to force of buoyancy, it said that fragmentation of Pangea occurred in two parts and the water of Panthalassa entered between the two landmass and hence Tethys Sea came into origin. Getting well now? Right? And this phenomena was referred to as opening of Tethys. Getting well? Again, he said that due to differential gravitational pull, the landmass which were near the North Pole and South Pole started drifting toward the pole. Na? It means differential gravitational pull causes equatorial movement. Getting well? This is second important aspect, and he said that tidal force causes particularly westward movement. So in this way, you see, Wegener explained the fragmentation of Pangea. Getting well? Na? Wegener explained the fragmentation of Pangea. Getting well? Explain the fragmentation of Pangea. So you see, actually, Pangea was the united landmass and it was surrounded from all the sides by the aquatic water body, you see, right? And due to the three forces, namely force of buoyancy, differential gravitational pull and tidal force, fragmentation of Pangea occurred. So you see the fragmented part of Pangea form is now in the form of the continent. Okay, so you can say that the continent is the fragmented part of Pangea and the water of Panthalassa which entered between the continent came in the form of the ocean. So thus you can say that continental drift theory of Wegener explained the origin and development of the continent and the ocean. Getting well now? Continent are the fragmented part of the Pangea and the water of Panthalassa which entered between the fragmented part of Pangea came from the ocean. It is clear. So that's why it is said that continental drift theory is capable to explain the first order landform. Okay, or you can say that it is capable to explain the origin of the oceanic and continental crust. Getting well now? Again, see, this was not the objective. Wegener's objective was not to explain the origin of the continent and the ocean. You must keep in mind, right? His objective was to explain, the fact which was not matching with the climatic condition of this zone, like existence of the coal mines in Alaska and Siberia, right? That is in polar zone, not matching with the climatic condition of this zone. It is clear now? So Wegener said that from in different geological period, the position of pole as well as equator shifted. Getting well now? Right? What he said? He said that during different geological period, the position of pole as well as equator shifted. Getting well? As for example, he said that during Silurian period, equator was passing near Norway. Getting well? It means Norway was at that time during Silurian period was existing in the equatorial zone. That is, you can say that it was high temperature zone and high rainfall zone, you can say. So that's why existence of coal mines in Alaska and Siberia is the common there. right? In particularly Alaska as well as the Siberia. Again, he said that during Carboniferous period, equator was passing from the north of North America. It is north of particularly Himalaya. But actually, you see, it was located, if this is India, okay, and this is Himalaya, it was passing during Carboniferous period. This was the equatorial position of position during Carboniferous period, and at that time he said, what he said? So at that time during Carboniferous period, actually South Pole was located in the central part of Gondwana land. Getting well? Near Natal province of South Africa. Getting well? So it means during Carboniferous period, the Gondwana land, which consisted of peninsular part of India, right? Africa, Australia, and South America was the polar zone. So that's why occurrence of boulder clay deposition and glossopteris vegetation deposition in this zone is the common phenomena, is normal particularly phenomena. It is clear na? So in this way particularly you see Wegener could define why particularly certain evidence are found which are not matching with the climatic condition of the zone. Getting well now? Now see, actually Wegener's continental drift theory became very popular. Getting well now? Right? He was expected to give answer of several questions. Actually, suppose particularly he said, he was the geographer raised the question, requested him to explain the origin of the fold mountain, which is the example of second order landform now. So he said that when landmass was moving, what was the explanation given by him? You see, what was the explanation given by him? He said that when landmass were moving, landmass were drifting, you can say, in westward direction, right? Suppose particularly landmass was moving in this way, right? Landmass means the part of Sial, the part of Sial. Na? So actually, if this is the part of Sial, you see, right? If this is the part of Sial, okay, this is landmass fragmented part of Pangaea, and this is particularly Sial. Na? Sial it is clear na? So this part is referred to as foreland, and this part is referred to as backland. Getting well? Wegener said that when fragmented part of Pangaea was moving, right, its foreland was in the form of lobe, means latakte hue aage badhna, okay, and during their movement, right, certain obstruction was caused, and due to the obstruction, the marginal part of this area, of this part, of this plate, got folded. Hence, particularly, fold mountain came into origin. Fold mountain came into origin. What explanation Wegener has given? Again, I am repeating. He said that when fragmented part of Pangaea was moving, actually its foreland was in the form of lobe, right? And it experienced certain obstruction along its path. Consequently, its marginal part got folded, and hence fold mountain came into origin. Getting well now? Fold mountain came into origin. Thus, you can say that, right? Actually, Wegener given the explanation to explain the origin and development of the fold mountain, but actually he was largely criticized. Actually, this assumption was criticized, right? Later I will explain why it was criticized. Okay. Again, you see, tried to explain the origin of Iceland Archen festoon. Those particular islands which are found in semicircular earth shaped is referred to as island Archen festoon. The examples are West Indies, Japan, etc. So he said that when landmass were moving in westward direction, certain part of it could not maintain the same velocity, and they were left behind, okay, and formed island Archen festoon. Why they formed island Archen festoon? This is clear, na? Certain part of Pangaea was left behind, and hence Iceland Archen festoon came into origin. Okay, so such type of explanation is given. Getting well now? Again, I am concluding the fact that Wegener continental drift theory, right, explained the origin of the first order landform. Wegener also tried to explain the origin of fold mountain, right, and he also tried to explain the origin of Iceland Archen festoon. Okay. But actually, you see, Wegener's theory became very popular because it was against the contraction theory and it was depending on more scientific evidence. That's why it got large scale acceptance now. But you see, Wegener's continental drift theory was largely criticized in later days. One of the basic point of criticism was the force applied by Wegener. Getting well now? Suppose particularly you see, the geographer said the force of buoyancy, differential gravitational pull or tidal force, right, cannot be so much effective to cause fragmentation of Pangea. Suppose if tidal force is effective, so for this the tidal force should be 90,000 times more effective as compared to that of the present tidal force. And if any time such a large force would have been operating on the Earth, it will adversely affect the rotation and revolution of the Earth and hence the existence of the Earth itself. Okay. So actually the first major criticism of Wegener was on the ground of inadequacy of forces. Second, particularly Wegener said that in different geological period, the position of force shifted now, but he could not explain it in scientific way. Getting well now? This fact is better explained on the basis of paleomagnetism. Getting well now? Right? Again, particularly you see, Wegener said that prior to Carboniferous period, the landmass were united and later the landmass got fragmented now. Okay, due to the three forces, namely tidal force, force of buoyancy, and particularly differential gravitational pull. But he could not explain the fact which forces were responsible to hold Pangea intact prior to Carboniferous period. Getting well now? Okay. Again, see, the explanation given by Wegener was for origin and development of the fold mountain was against the basic assumption of this theory, because you see there were two basic assumptions of Wegener's hypothesis. First was prior to Carboniferous period, the entire landmass were united to form a single landmass known as Pangea, and Pangea was surrounded from all the sides by the extensive water body known as Penthelasa. Getting well now? Okay. And second basic assumption was upper part of Pangea is made up of Sial and it float over Sima, and movement of Sial over Sima is frictionless. There is no friction between Sial and Sima. Getting well now? Right? Movement of Sial over Sima is frictionless. Getting well? So as far as the question, these are the two basic assumptions of this theory. Getting well now? Right? So actually he said that when landmass was moving, right, its foreland was in the form of lobe and experienced particularly a obstruction, right, or friction. Consequently, the marginal part got folded to form fold mountain. Okay. Now the question was raised that if there is no friction between Sial and Sima, movement of Sial over Sima is frictionless, then how it is possible, how the obstruction is possible? It means if you will consider this obstruction effective, then it is against the basic assumption of the theory, right, and it will cause the collapse of the entire hypothesis. Getting well now? So this is also against the basic assumption of the theory. Okay. Against the explanation given by Wegener was against the basic assumption, because he said that some part of Pangea, okay, while moving in westward direction, or some part of the continent while moving in westward direction could not maintain the same pace as, right, could not maintain the same pace and left behind to form Iceland arc and festoon. Getting well now? Actually, the argument, he given the argument that these parts were associated with the oceanic crust. Getting well? Okay. Actually, this part was having low velocity comparatively because they were having the association with particularly oceanic crust. This argument was given by Wegener. But you see, continents are made up of Sial and oceanic crust are made up of Sima, you know, right? If there is no friction between Sial and Sima, then how the association of this part with the oceanic crust is possible? Okay, so this is also against the basic assumption of this theory. Getting well now? So these are the important limitation of the particularly continental drift theory. So that's why particularly you see later, right? Actually, H has propounded more wider concept in the form of plate tectonic theory, which effectively and scientifically explain, right, all these facts effectively, like particularly second order landform. Again, particularly because plate tectonic theory is based on certain scientific evidence, like paleomagnetism. So that's why it put more effective explanation for origin of fold mountain and island Archean festoon based of rock. Repeat it, it will be highly helpful to continue. Okay.